What is up, ladies and gents? We're going to be continuing on with lesson 10.3 today. Should be finishing it today. Going to do two examples. What's going to separate today's lesson from the previous one is that the center of our ellipses are no longer going to be at the origin. So we're going to be moving the center of these and seeing what that does to our equation. So there's going to be a lot of information in this picture here, but try not to get too overwhelmed. I really just want you to hone in on this equation, okay? This is when we have one that's stretched horizontally, okay, an ellipse stretched horizontally, and here's when we have one stretched vertically. Again, the only difference is, look, just the A's are switched. A is always the greater number, so it's going to be, again, stretched horizontally if A is under the Y rather than A being under the X. Okay, so the only thing that's going to change, and this is kind of similar to how parabolas worked, circles work, we're going to have a center at HK. Okay, so it'd be X minus your X coordinate, Y minus your Y coordinate. All right, so let's go ahead and take a look at our first example. It says find the equation, we're doing of an ellipse, with its center at 2, -3. One of the focuses, or one of the foci is at 3, -3, and one of the vertices is at 5, -3. So I would suggest doing kind of a quick little graph. Doesn't have to be super accurate, but as long as it can give us a sense of where everything is. So it says we have a center at 2, -3. Oops. Okay, right there. It's my center, 2, -3. It also tells me I have a focus at 3, -3. Call that right there, 3, -3. Right there. And it says we have a vertex at 5, -3. 5, -3. Right here. Okay, and this should kind of tell me where everything is going to be. You see here, distance from my center, which is this point at 2, -3, to my first vertice, that's got a distance of 3. So my other vertices should be over this way, to the left, a distance of 3. So my other vertices should be at -1, -1, -3. Okay, that's my other vertice. And then this focus, that's a distance of 1, so I should go 1 to the other side. And that is 1, comma, -3. So this is F1, F2, we'll call this the center. Here's vertex 1, vertex 2. Okay, so those are my points. Now, what I don't know is how to stretch them horizontal or vertically. We see this is stretched horizontally. I'm not sure how to stretch it vertically. I don't know if it's going to look something like that, if it's going to be less stretched out and be something like this. Oh, that didn't work. Or if it would be less stretched out, something like this. Okay, that's what we need to find using that b squared equals a squared minus c squared formula. Okay, so let's go ahead and do that. But first we need to identify what a is and what c is. So it's a little different. We can't just take 5 and say that this is a now. What we really want to do is take the distance from the center to that vertice, which we established was 3. So technically my a is going to be 3. Okay. I don't know what my b is. My c is going to be the distance from the center to the vertice. So my c should be a distance of 1. And then we're going to use that to find our b. So we have a b squared equals a squared, which was 3, minus 1 squared is just 1. So b squared equals 9 minus 1 gives me an 8. B will equal the square root of 8, which is 2 square root 2. Okay, so B I should get 2 root 2. Okay. So if I'm writing my equation now, okay, I should have x minus, what is my x coordinate of my center? That is 2. So x minus 2 squared over, now it's stretched horizontally, so my a is going to be under the x. So this is 3 squared, to be 9, plus y minus my y coordinate. My y coordinate is a negative 3, so we're going to do a y plus 3 squared over, we got 2 root 2 for b, but 2 root 2 squared, well, we know what b squared is, that's a, or 8, not a. So this should be an 8. And then an ellipse is always equal to the equation equal to 1. Okay, so that is how we would find that equation. Let me know. I know that's maybe a little tricky. Hopefully I didn't go too fast, and hopefully I didn't skip over some things that maybe you had missed from last lesson that you're maybe still a little confused on. Until I hear questions from you guys, I'm not too sure what to do about that. So hopefully you guys did well, and we're going to do one more example, and then we will call it for the week. Friday we'll have our progress check as usual. As usual. So let's do the next one. Find the vertices and foci. And here's my equation. 4x squared, 4x squared minus 8x plus y squared plus 4y plus 4 equals 0. Okay, so this right now does not look like our equation for a ellipse, right? We're going to have to use a method that you guys love. It's one of your favorites. We haven't used it in a while. If you remember how we switched when we did parabolas back chapter 3 or 4, we used complete the square to move from standard form to vertex form. So that's what we're going to be doing here. So we want to complete the square with the x's and complete the square with the y's. All right. So here's what it's going to look like. Let's focus in on the x's here. All right. First thing we want to do is factor out a 4 from the x's. So this should be 4 times x squared minus 2x. The y's we don't have to factor anything out of. So we'll leave that as a y squared plus 4y. And we're going to move the constant over to the other side. All right. Next, remember how we complete this square. This is a 4 times x squared minus 2x. Take half of that x term. So half of 2 is 1. You square that, which is also 1. We do a plus 1 minus 1. Okay. If that is like, whoa, what the heck did we just do? It's from a couple lessons. We did this probably 2 or 3 times throughout the year where we really focused in on complete the square. But that's what we're doing here. So remember, it's half of this term squared, which half of 2 is 1. Squared is still 1. We add that and subtract that. Let's complete the square for the y's as well. This plus y squared plus 4y. Half of 4 is 2. You square 2, and that goes 4. So we do a plus 4 minus 4. Still equals negative 4. Right. Remember, we're going to take these terms and factor those. So this is 4 times x minus 1 squared. So we used these 3 terms to factor to x minus 1 squared. But then what happens to this minus 1? If it's going to come out of the parentheses, it's going to be a minus 4. So let's do the same for the y's. That's going to factor to y plus 2 squared. Okay, minus 4 equals negative 4. Move these two constants over to the other side. So together, minus 4 and minus 4 is a negative 8. But if we add that to a negative 4 over here, it's going to give us a positive 4 on the other side. So we have 4 times x minus 1 squared plus y plus 2 squared equals 4. Okay, so this is looking much better. Only one thing we want to do to change this is to set it equal to 1. So we divide everything by 4, both sides of the equations. So this is in x minus 1 squared plus y plus 2 squared over 4 is equal to 1. So now it's in that standard form for an ellipse. So we need to identify what is A and what is B. Remember, A is always the larger number in the denominator. There's technically a 1 here, right? So A is, well, technically that's A squared. 4 is A squared. So A is actually 2, right? Because if you think of the equation, what do we plug in there and square it to get 4? Well, we plugged in 2. B is 1. And we want to find C because we need C to find the focus. So let's go ahead and do that. B squared equals A squared minus C squared. So 1 squared is 1 equals 2 squared, which is 4, minus C squared. Negative 3 equals negative C squared. 3 equals C squared. C is going to be the square root of 3. Okay, which is going to be kind of weird when we're finding our focus. So let's kind of graph this to see what's going on, to figure out where my vertices are, where my foci are. So my center for this one was 1 comma negative 2. Remember, you get that from h and k here. So 1, negative 2. That's my center. My vertices are going to be vertical to that because I'm stretched more vertically because my a is 4. All right. Or sorry, my a is 2. A squared is 4. So my vertices are going to be 2 above the center and 2 below the center. So my 2 vertices are going to be here and here. So this is V1, which is at 1, 0. This is V2, which is at 1, 2, 3, 4. So this is 1, negative 4. All right. Next, we need to find our foci, which, remember, I'd mentioned our foci are C away from the center, a distance of C away from the center. So adding root 3 to the center, or the y-coordinate of my center, which, remember, this was 1, negative 2. That's my center. We're going to get a decimal, but we can just write it as whatever plus root 3. So it'd be negative 2. We can add root 3 to it. So wherever that is, it'll be somewhere here. This might not be super accurate, but this is F1. We'll say this is at 1, negative 2 plus root 3. And then we'll have another one down here at 1, negative 2 minus square root 3. Okay, and that's going to be my 2 vertices, V1 and V2, and my 2 foci, F1 and F2. Okay, so those were my vertices and foci. That was probably the hardest one we've done in a while. Yeah, so if you don't follow that, we're going to need to get in on Zoom or whatever. Hit us up. When do we meet? Wednesdays? Wednesdays 12:30? It's Wednesdays at 12 or Wednesdays at 12:30. I have that information. It is Wednesdays 12:30 pre-calc. For those of you who didn't know that, which if I had to guess, it's probably like half the class. So that is it for today. That is it for lessons for the week. Hope you guys are doing well. Almost done. Yeah, that's all I have to say. Talk to you guys later. Peace.